The Internet of Things clearly is a new buzzword of the week. It means all things to all men. Basically, it's any kind of IP-connected device is the way that we define it internally. These are the sorts of devices that you find all over your homes. Everything from TVs, video players, DVDs, kids' cameras, to work and car research as well.
I think one of the things that we're seeing around a lot of IoT, internet-connected devices, is that there's a lack of forethought around information security when these devices are being created, both from a hardware level and a software level. Because we're talking about much smaller scale devices than traditional computing models, the effective cost of adding good security to the development time of these devices on a physical and a software level is much greater in terms of a proportion of the device cost. So a lot of the vulnerabilities that we're seeing are the same traditional vulnerabilities that have been eliminated from a lot of traditional computing platforms and are now creeping their way into these newer types of devices. Particularly when you're dealing with a lot of these devices containing personal information, things like wearables or baby cameras, monitors, devices in your car, for example.
So one of the things we've been working on for a couple of years now is a number of different car manufacturers, looking at their products, looking at particularly the infotainment systems in them that provide your media, your GPS. A lot of them are more functional than you'd expect them to be. GPS information, for example, often being used for car tracking as well, but trying to work out whether that is as tightly contained within the platform as it should be, whether it can be accessed remotely, can it be used, for example, to track you for nefarious purposes as well as for recovering your car if it gets stolen.
Another thing we've been looking at very recently is the proliferation of fitness bands. So a lot of these devices are now able to synchronize and upload their information either directly to the web or via other communication means. So Bluetooth back to a computer or some other form of local communication, for example, USB. And so trying to examine the way, particularly the ones that are designed to communicate locally, how the information can be extracted from those and whether it can be taken by people for purposes other than those that it was expected. For example, loading malicious firmware onto one of these devices so that you could use it to track somebody's movements through GPS.
IoT devices are the kinds of hardware devices that have actually been sort of proliferating into our homes for a considerable period of time. There's been a lot of news in the press recently about some of the Samsung TV issues with the firmware sending off audio streams for audio commands back to back office systems. We've had a look at, as I said, baby monitor cameras have been in the press as well for containing trivial backdoors, often calling back out to remote internet systems, providing connectivity.
I think at the same time as we're starting to see a greater interest by security professionals in understanding the vulnerabilities in these devices, we are on and only slightly behind the curve in terms of malicious users actually trying to utilize them. So the number of real vulnerabilities that have been exploited in the wild as yet seem to be fairly low. But obviously as traditional computers become harder and harder to break and more secure, it's inevitable that malicious users out there are going to start using these devices more frequently as an attack vector.
We have seen practical examples of people scanning the whole of the internet, for example, using home routers as the attack platforms. That was done about 18 months ago now, I think, and the firmware was modified on home routers en masse to use that as a scanning engine. That was being done allegedly for a research project. There's a fine line between research projects and malicious projects, and there's a good argument to say the output of the information from that project has been used to feed both good and bad research projects, because the information then became available en masse that wouldn't have been there previously.
In a lot of cases, it's a very much a dual-based thing. So in terms of personal devices, we've seen a proliferation of mobile personal devices being brought into the workplace. And it was at least 10 years ago where the Furby as a listening device was thrown around as a concept. And that's really a very early example of Internet of Things devices being broken. So partly in terms of data leakage, it's going to be an easily accessible method for people to get data out of businesses, whether it's their device that they're bringing in and trying to use or whether it's trying to utilize somebody else's. In a broader sense, we're starting to see a lot of businesses, particularly those around, for example, highways management, a lot of things like dot matrix signs on motorways starting to become internet connected. So any business who starts to find that actually the convenience provided by connecting their devices to the internet all becomes a target. And a lot of businesses don't necessarily conceive those risks because they're on this non-traditional platform.
As most of these devices are generally just small compute platforms in the wider sense. They may be branded up in a physical shape to do a particular task, whatever that might be. The platforms themselves are generally quite flexible, and most businesses are allowing them to connect out to the internet, to download firmware updates. That's effectively a means of reprogramming a compute agent inside your security perimeter. If you can get control of the machine that that's connecting to, be that by an attack on the vendor or on DNS, then you can effectively create a Trojanized platform for further attacks within an enterprise without ever going near the perimeter.
A lot of the components that are being used are very much reused open source components, ones that are easy and cheap to produce, ones that can be bought in on bulk from a lot of different places. And although, as Stuart said, they might all be boxed up into a pretty package, they're actually easy to assess using a lot of common techniques. In a lot of cases, the interfaces will be slightly different, so you have to start being imaginative around how you interface with them. But most of the techniques are fairly similar to ones that we've had for quite a few years.
And in terms of procurement, a lot of it comes down to the traditional supply chain routes that we've been looking at for many years as part of good IT governance, making sure that you're buying sensible branded products from known and trusted locations where the vendors have got a good security record, they are issuing updates and patches, they understand what you've got and what it's doing. If you are bringing in components that you think are more risky, or you're operating in a higher threat environment, looking at performing your own testing on the devices first, or putting them into isolated VLANs, effectively treating them like an untrusted server component effectively on your network, and taking the traditional mitigation measures that we have been for unknown devices for many years. I think IT departments generally have ignored anything that isn't what they would consider a standard server or a standard workstation, or that bring your own device policies are coming into play now. So they understand what IT kit looks like. They generally have a fairly poor record of looking after devices that either they don't consider that they own per se, be that a voice platform that's been brought in, or a building access and management platform, security systems, camera systems. If they're not explicitly given control over a set of technologies, then generally they won't see it within their remit to manage them actively, and that can pose quite a significant threat to the business.
And in a lot of cases, the IT department of the business won't necessarily be informed of the fact that these devices are being brought in, because if devices are being brought in, for example, by facilities, if their building management system has been brought in from a third party, they simply ask for switch ports, and a network department who are not necessarily reviewing things in full detail will simply provision those, and they won't even see that these devices are coming into scope. And a lot of devices, particularly when they're communicating in non-standard methods, so if they're communicating over Wi-Fi, over Bluetooth, or directly across the internet from field locations, they might not necessarily be perceived by the teams purchasing and implementing them as internet security devices, and therefore they'll bypass the whole IT department and the IT security system altogether.